Today we're going to explore how to expand and condense logarithms. This property will help us later when we actually need to solve equations to find the value of a variable. Let's explore why this is important. If I have a logarithm, such as the one below, and I want to convert it, we know that what it's equal to becomes the exponent. So for example, the base becomes the base, the answer becomes the exponent, and what's remaining is what it equals to. Now, what if that exponent is more than just a number or a variable? What if that exponent is an expression? Well, we need some support on what to do if that exponent is larger than what we've dealt with so far. A couple of reviews about exponents. These exponent rules very closely tie into logarithms. So for example, we add the exponents when we're multiplying the bases. So this would become 2 to the 4 plus 3, which is equal to 2 to the 7th. This property or this rule is going to carry over into logs. When we subtract, we are dividing the bases. So this becomes 2 to the 5 minus 2, or 2 to the 3rd. And when we multiply the exponents, we distribute. So therefore we have x to the 8th. If you know these rules well, the logarithm rules will be easy to follow along. You'll definitely want to have this down in your notes. The properties of logs, and it includes natural logs, meaning wherever I see the word log, I can replace it with ln, or natural log. So the first rule is our product property. For the product property, if you're multiplying two values within the log, you can expand it into separating them and changing it to addition. The quotient rule. If you have a value divided by another value within a log, you can use the quotient property to convert that to subtraction. So this is called, again, expanding. And the power property. The power property says that whatever's in parentheses, its exponent can be brought out front to be multiplied. When looking at these properties, if you go to the right, that's called expanding. You're going to see that keyword a lot. And going to the left is called condensing. So just as it sounds, if I'm expanding, I'm making it larger. I'm spreading out the logarithm. Condensing is I'm trying to condense that logarithm into a smaller problem. This will make more sense as we work on examples, but definitely get these rules written down. Let's take a look at our first example. We want to expand this logarithm. It is multiplying, which changes to adding, which means I'm going to have two log base 3's with a plus sign in the middle. And whatever values I'm multiplying become my main value of those two logs. So it changed from multiplying to adding. I expanded the logarithm. Let's do the same thing here. This time you'll notice I have 1, 2, 3 values, which means I should have 1, 2, 3 logs. I'm multiplying, therefore I'm adding. I have the log base 10 of 6, the log base 10 of x, and the log base 10 of y. Condensing means we want to go the opposite direction. So I'm going from a large to a small. Currently I'm adding. They all have that same base, which they need. So let's write it as one base, log base 3. Instead of adding the 3 values, we are going to multiply them. Now, if you can simplify, definitely do so. So in this case, let's take care of that simple multiplication. And let's say that we have 154. I still want to see this work though. I want to see that you know how to condense that logarithm. Let's take a look at some examples of the quotient property. The quotient property says that we're going to change the dividing into subtracting. If there is no base, we know that's common log, so it's base 10. If you want to include the 10, that's fine. The top number comes first, and we subtract the common log of the denominator. Let's take a look at the reverse operation. We want to condense. Natural log, so this is true for logs or natural logs, we're subtracting. Let's create one natural log. The first number goes on top, the second number goes on bottom. It's that simple. Make sure if you can reduce, do so. So let's simplify this down to 1/4. Notice on all of these, I'm not solving at all. I'm just expanding or condensing. And if I can, simplify a little further. Here I have log base 4. Therefore, I'm only going to have one log base 4. My first number goes on top. My second number goes on bottom. Parentheses will help identify that we're taking log base 4 of the whole fraction. So it's best to use parentheses to clarify what you have written. Let's take a look at the power property. The power property says that whatever the exponent is can be multiplied by the log out front. So now that 2 is out front of the entire log. Now that 2 is affecting both of them. In this case, I also have multiplying, so I'm going to take that a step further, and I'm going to separate that and expand it into log base 4 of A plus log base 4 of B. Now you need to have this 2 outside of parentheses because it affects both logs, just as it did before we expanded. Here we have multiplication. But notice I've got a square root. So that square root's currently just affecting the 7. So let's start off by expanding our multiplication. We have a log base 5 of square root of 7 plus log base 5 of x. Square root of 7 is also written as base 5, 7 to the 1/2. So no square roots, cubed roots should be left alone. We want to convert those to fractional exponents. So my final expansion is going to be to bring that 1/2 in front of the log base 5 of 7. Now we don't need parentheses on this one because the 1/2 only affects the 7. So we don't need any parentheses. We want them to be separate logs. Let's look at the reverse. I'm going to condense, which means the value out front becomes the exponent. So here I have the common log of 6 to the 1/3. Well, 1/3 also means the cubed root. So we're actually taking the log of the cubed root of 6. So when you're condensing, you want them to be written as roots. When you're expanding, you want them to be written as fractions. Let's take a look at more examples that provide multiple properties within one example. The order in which you solve these does matter in the sense of where your parentheses are going to be located. So let's start off with the 5, and we bring that out front. Next, we have division. Division becomes subtraction. Now remember, this 5 is affecting all of it, so we want to keep that 5 in front of everything. So we have the common log of 6x minus the common log of 11. Now I also have a 6x here. Well, that's considered multiplication. So now I want to expand and change it to the common log of 6 plus the common log of x minus the common log of 11. So there should be no multiplying, no dividing, and no exponents remaining when you're completely done. Let's look at condensing. First thing is the numbers out front become exponents. So this becomes log base 3 of x to the 4th minus log base 3 of y to the 20th. Next, I am subtracting these logs. Therefore, that's going to convert to dividing. So x to the 4th goes on top, y to the 20th goes on bottom. Since it's a fraction, let's show that all of that is together. So in condensing, I should have no multiples out front, I should have no subtracting, and no adding remaining. So what's the purpose of learning expanding and condensing? It's so that later on we can solve. So I'm going to show you this example, but you don't have to know how to do this for our immediate next assignment. So let's practice condensing this particular equation. The first thing is any multiple out front becomes an exponent. This is the common log since we have a base of 10. Next we have subtraction, so I'm going to change that to dividing. So we've got 3 over x squared. Next, if we take a look at this, we have a couple of options for solving. I want to get x by itself. So the first option is to convert it to exponential form. Because all of this is to the log, I can't really do a whole lot with it. So the moment you get stuck, you got to think convert. So if I convert this, now it's going to be the exponential function where the base becomes the base, the answer becomes the exponent, what's remaining becomes the answer. I'm going to multiply both sides by x squared. I now have x squared 10 to the 16th equals 3. I'm now going to divide both sides by 10 to the 16th. My goal is to get that x by itself. I have x squared equals 3 over 10 to the 16th. And the last step to get x by itself would be to square root. So the square root of 3, 10 to the 16th. Now from here, you could find the decimal value and carry it through in your calculator. But I want to see that process of getting x by itself. Plus, you don't want to write down a bunch of decimals for each step. So at this point, then I could type that in my calculator to get an approximate value depending on what the directions are. So that's the purpose. Today, we're just going to work on expanding and condensing. So I'm just looking for this step. But in the future, the reason why is so we can keep going and solve for that x value. In preparation for the next class, you just want to make sure that you have these notes in your notebook ready to go so that we can discuss expanding and condensing in class. Make sure you keep practicing those exponential to log rules and then also your natural log rules. So keep reviewing those so that you don't get behind and confused because we're going to tie all this together in the end. So make sure you take your time and we'll see you next time.